Hi, my name is Farshad Farbakhshan.
Hi, my name is Blake Salisbury.
Hi, my name is Anthony Lee. We are Team Mind Group, creators of the Environmental Sensor Module.
What is the motivation for this project, you ask? I'll tell you what it is. It's outsourcing. It's happening and you can't do anything about it. It's cheap and it works. But what about the standards? The standards are low, but the wages are cheap. But what are you going to do when the standards aren't good enough for you? That's where the ESM comes in.
What is the ESM, you ask? It's an environmental sensor module. This thing keeps track of 4 environmental variables: temperature, pressure, humidity, and air quality.
So you've got all your measurement readings in this box, but what can you do with it? Well, you can hook it up via RS-232 to USB, BAM, to a laptop, which runs the GUI, where you can communicate between these two things. It not only outputs the data you read, but you can also configure the alert limit, max and min, the sampling frequencies, view graphs, and much more. All you want.
Alright, so we've been running the ESM for about 10 minutes now. We've got it connected to a computer via USB. We've been tracking variables such as temperature, humidity, pressure, and air quality. So we're going to use the GUI to show you some of the features of the project. The first feature I'd like to talk about is the ability to view graphs depicting time versus the variable. So here we have humidity versus time. So as you can see, the humidity has been hovering around 45% within this room. We can also view other variables. So let's take a look at temperature. Let's view graph. So as you can see, the temperature has been oscillating around 22.5 degrees Celsius or so. Now let's check out air quality graph, and it's been bouncing around up to 300 particles per foot squared. Foot cubed. So that's the first feature I'd like to show you. The second feature that's really cool about the ESM is the fact that you can actually output all this log data into an Excel file or a .csv file, which stands for comma separated values. This data can then be analyzed further in Excel or in MATLAB. We also have a output logged errors feature, so anytime a threshold is passed, you can use the ESM to export that data to be analyzed further. Another cool feature about this is that you can actually set the sampling frequency, which is done via this part of the GUI. So we can go to the variable that we want to adjust, such as air quality, temperature, humidity, power monitor pressure, and then adjust the set sampling frequency from 10 seconds all the way up to 24 hours, and then hit configure.
Blake Salisbury here. We're going to be looking at outputting log data from the environmental sensor module. Looking at the GUI here, we see that we have an air quality graph, and it's let's update it real quick. So far we've done 12 samples at a rate of 1 minute for the sampling frequency. And what we'd like to do now is output these values into a CSV file, and this will also do all the other environmental variables. So we go up here to the upper left hand corner of the GUI, output log data. We click on this. We're going to save this as log on the desktop. I should save it as a CSV file. Okay, we're going to retrieve that from the desktop, and we come in here. And what we see here is we have the air quality. All the air qualities that we were showing on the graph are shown. We have the temperatures, which are staying pretty consistent. We have humidity and pressure. One interesting thing to note here is that the NAs in the temperature right here represent errors, which means that it went outside the threshold. So if we go in here and we output the log errors, which is the button just to the right of the output log data, we're going to call this error, and this will save on the desktop. We'll then come to the desktop again, and we see here in the 23rd and 24th sample of the temperature, where there was an NA in the regular recordings, there's now there's recordings for the errors, which is how far above the threshold it was. This concludes the demonstration of logging the variable.
This is a demonstration of the alert limit feature of the ESM. So if we go to the computer, what we can do is we can set the alert limits by clicking the button and setting it for the variable. So for now, I'm going to go ahead and set the max limit to be about 10 degrees Celsius because I know that the temperature is obviously higher than 10 degrees Celsius in this room right now. Minimum, I'll leave at 0. And so if I set the alert limit, the LED should turn on the ESM, indicating that there's a violation. The temperature reading is much higher than what we want the max limit to be. But now if I set the max limit to be 100 degrees Celsius, which obviously it's not that warm in here, since it's just the room, and hit the set alert limit button, the LED should turn off for temperature, as seen on the ESM. This experiment can be repeated for every other environmental variable, and this is just a quick demonstration of the alert limit settings feature for the ESM.
This is an overview of the block diagram for the environmental sensor module. One of the primary inputs to the system is the VDC main. This is a 24-volt input that powers the ESM. VDC main serves as an input to the voltage regulator unit block, which is responsible for regulating the voltage to the appropriate levels for each of the sensors, such as the air quality sensor, temperature sensor, humidity sensor, and pressure sensor. It is also responsible for regulating the voltage to the appropriate level for the microcontroller unit. The other inputs to the system come from the environment itself and is read by the air quality sensor, temperature sensor, humidity sensor, and pressure sensor. The temperature sensor, humidity sensor, and pressure sensor interprets the environment as a voltage value and then feeds it as an input to the microcontroller. The microcontroller is then responsible for converting this analog value into a digital value using an analog to digital converter, which then sends this digital data onto a PC running the GUI for the ESM. One difference in our current design compared to our original design is that the air quality sensor now sends its digital data directly to the PC running the GUI, as opposed to sending some sort of analog data to the microcontroller itself. This is because the air quality sensor now outputs RS-232. The primary output to the ESM for the block diagram is the log data, which contains all the measurements recorded by the ESM for all of the different sensors. The final block to talk about is the case itself that houses all the internal components of the ESM. The input to the case block for the ESM are all the different environmental factors such as air quality, temperature, humidity, and pressure that the ESM measures. The output to the case block is the heat that the ESM actually generates. This concludes the block diagram overview for the project.
Alright, so the first unique design consideration I'd like to talk about is the air quality sensor. So most air quality sensors, which are also called particle counters, may cost up to $5,000 for a quality one that counts particles in the air. Obviously, one of our system requirements was that the entire system costs less than $2,000. So we decided that we'd have to find something a lot cheaper, and that's why we went with the Dylos air quality sensor, which is around $500. So it does everything else that a particle counter does, but it approximates it. So what's unique about this is the fact that we achieved a very low price point, but we still met the system requirement that we needed for the accuracy of the particle counting.
A unique design consideration that spawned off of the air quality sensor that we use was that originally the original intention was to send the air quality signal into the microcontroller, as well as using it with the temperature, the humidity, and the pressure sensors as well. But the difference is that since the air quality sensor we use is a particle approximator that hooks up to the PC instead, we had to modify the code so that the microcontroller itself keeps track of all the other sensors, whereas the PC and GUI is responsible for keeping track of the air quality sensor.
Class of 2013, I'd like to give you a helpful tip. I think if you have a sponsor, you should communicate with them very clearly. Don't be afraid to email them whenever possible, and talk and text and do everything you need to.
Alright, future seniors, if there's one tip I gotta tell you, It's to be prepared. Fall term, it's your research term. Everything you do in that term will affect the outcome of your project, so make sure you research well.
All right, future seniors. One tip I have for you guys is just to have fun with the senior project, because you're going to be working out for the entire year. You might as well have a good time with it.